Now, what does this whole picture here represent? Well, first of all, this blue line here, or this blue graph, is the graph of a parabola. Now, I've actually drawn this one freehand. I know it's not looking great, but it's the best I could do. Now, what I want to do in this video is to show you how to derive the equation of a parabola. But before we get there, let's deal with a few terms connected with a parabola. First, it's the focus or focal point. The focus or focal point of our parabola is a fixed point which I have marked F, and it's the point A0. In other words, x is equal to A, y is equal to 0. Then we have the directrix. The directrix is a fixed line, and for this particular parabola, the directrix is drawn in red, and it's the line with equation x is equal to A. In other words, it's the line that passes through the point x is equal to minus A, y is equal to 0. Now, then we have the locus. What is a locus? Well, a locus is just the path traced out by a point. I will repeat that a little slowly. A locus is the path traced out by a point. Lastly, it's the vertex. The vertex is the point where the graph tends, the parabola tends. In this particular case, our vertex is at the point 0, 0. Now, the point P here with coordinates x, y is just a general point. It's a point on the graph of the parabola. Now, what is the equation of a parabola? Well, let's start with the definition. What is a parabola? Well, a parabola is the locus of a point which is such that its distance from a fixed point, the focus, is equal to its distance from a fixed line, the directrix. Let's repeat the definition. A parabola is the locus of a point. In other words, the path traced out by a point which is such that its distance from a fixed point, the focus, is exactly equal to its distance from a fixed line, the directrix. Well, let's suppose this distance here from P to the directrix is D. And let's also suppose that the distance from P to the focus is equal to C. So our parabola, the definition of our parabola is that the point P, as it moves along the parabola, will always have that D is equal to C. So first of all, we must have the condition is D is equal to C. At any point along the parabola, whether P is here, P is there, P is there, D is always equal to C. Now, let's try to see if we can convert that into algebra. What is the distance C? Well, let's drop a little perpendicular here. So we have that right-angled triangle. Well, then the distance C from Pythagoras' theorem is we have C is equal to the square root of x minus a all squared. I'm quoting the distance formula here, plus y squared, all under the square root sign. And what is our distance D? Well, this line, of course, is parallel to the x-axis, so the distance is just simply equal to x minus a, which is x plus a. So D is equal to x plus a. Now, we are given that the distance C is equal to distance D. So we can write now, let me stand over here. So our x minus a, x plus a is equal to the root of x minus a all squared plus y squared. So let's try to square both sides to get rid of the square root sign. So the left-hand side becomes x plus a all squared is equal to x minus a all squared plus y squared. Let's expand both sides. The left-hand side becomes x squared. Let me try and get a bit of pen. This one is packing up. So x squared plus 2ax plus a squared is equal to x squared minus 2ax plus a squared plus y squared. I hope you can see my tiny little writing there. But the right-hand side is x squared minus 2ax plus a squared plus y squared. Let's cancel out the like terms on both sides. Well, there's an a squared here and another a squared here. There's an x squared here and another x squared here. So we are left on the left-hand side with 2ax, and on the right, we are left with minus 2ax plus y squared. Transferring the 2ax to this side, we have 4ax is equal to y squared. This is the equation of a parabola with focus at the point A0 and with the directrix being the line x is equal to minus a. Now, that would be the equation of our parabola. What I want you to try here is to find the equation of a parabola with the focus f at the point 0, 1, and the directrix, the line y is equal to minus 1. I'll give you a clue. It's going to be looking like this. Here is our y-axis, there is our x-axis. And this thing is going to be like that. And our directrix, your directrix, is going to be a line down here. The line y is equal to minus 1. And our focus will be here, which is the point F with coordinates 0, 1 as required. So I want you to find the equation of this parabola and give your answer down in the comments below. If you like this video, please do subscribe and share. Till we see you next video. Bye-bye.